is again our backdrop of what I talked about, big data. What is big data? Which data I can actually classify as an example of big data. Why we are coming to big data, why our SQL server was unable to do this stuff, and again the different use cases where big data will actually find its mention. Now once we are done with this, once we are clear in our head that SQL server and Oracle is not something which is going to help me, which is going to help me is something else. So again, before I talk of Hadoop, let me again talk of something called NoSQL. I told you I will talk of NoSQL as well. What is NoSQL? NoSQL is not only SQL. The moment people heard the name NoSQL, what they infer out of it is, we are not going to use any SQL, which is not the scenario. The scenario is not only SQL. We will definitely be using SQL, but we'll be using something apart from that as well. So that's what the name NoSQL suggests. Now, this is a new breed of technologies coming in, NoSQL databases. So basically there are 5 flavors of NoSQL. First one being key value stores. Document-oriented data stores. White column stores. Then we have the graph data stores. So these are different types of NoSQL databases we'll find. Some people who had got a chance to work with NoSQL, their NoSQL would fit into some of these flavors as well. So example of key value stores. So again, we'll talk about each of them in detail in the upcoming sessions. But as of now, I'll just give you one example of each of them. So key value stores, again, the examples are Redis, DynamoDB, so again Redis is the database name. The way we have a SQL server, the same way we have a Redis. SQL server is a type of SQL database. This is a type of a NoSQL database. DynamoDB is a NoSQL DB of Amazon, which is again of the type key value data store, which will store everything in the form of key and values. Document-oriented data stores will store everything in the form of documents. Example is MongoDB, CouchDB. White column stores, inverted, RDBMS upside down. Example of this is again Cassandra, HBase. Again, we'll talk about these in detail when these will be coming in the topics. Graph data stores. There's the Neo4j. There is the Apache Giraffe. All of them are, both of them are graph data. Hybrid store is something which does not follow one architecture, follows a mix of everything. Example of this is OrientDB. Some of these databases which are doing very good. One is Cassandra. Both of them individually are big data solutions. They have their offerings where they can actually do proper solutioning in terms of problems related with big data. Second, this is something which everyone calls the future. These are the databases which will come and take some portion out of SQL Server and Oracles. Now, graph I'll show you what the future has for us. This is again a Gartner graph. You can search it on the internet, the changing landscape. The graph name is the changing landscape. Here what is shown is the smaller chunk over here is the RDBMS, and a much bigger chunk will be captured by something called NoSQL. So, and here is a small part over here, Hadoop. So Hadoop is a type of NoSQL data store, which again has its own method of storing things, processing things. So again, this diagram should be in our mind. An image of this diagram should be in our mind for quite a long period. That where does Hadoop fit into the full ecosystem? And all of this is there to handle the problem of big data. So one very informative thing we get out of this image is Hadoop is not the only solution. So Hadoop is just one of the different solutions which are available, which can solve big data. But again, Hadoop has become so popular, it has almost become synonymous with the NoSQL and the big data. But again, we'll just see there are other technologies as well, which are also good and which may also come up as better alternatives to Hadoop. So what is Hadoop? Hadoop is actually a framework or a library. So here we can see that the Apache Hadoop software library is a framework or a platform that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. So all it is saying is this is one system, this is another system. Both of them are a part of one cluster. It has some storage, it has some RAM, it has some storage, it has some RAM. What I'm going to do, I'm going to store my large data across both these machines, use both these processors to parallelly run on that data and get me the output. That is what Hadoop is all about. So again, if you see, if you actually see, and again, if we feel 2 nodes is something less for our cluster, I can add a 3rd node as well. This is called scaling up. My system should scale. This is what it means. If I want to increase the capacity, I should be able to do that. Please see the second point again. It is designed to scale up. Scale up means again 2 to 3. From single servers, there's a single server, to thousands of machines. We can add as many number of, each offering local computation and storage. It can store something, it can compute as well. Again, if you see over here is a framework that allows for distributed processing of large data sets across clusters of computer using simple programming models. So again, this is again talking about what actually Hadoop consists of. So Hadoop consists of 2 things. How I would like to say it is that Hadoop is this platform. Any data analysis platform I talk of, it has 2 components. Data storage and data processing. There has to be a component who stores the data. There has to be a component which processes the data. So in our case, see over here, HDFS is the component which stores the data. MapReduce is the component which processes the data. So this is HDFS. What is HDFS for? It is Hadoop, distributed file storage, and MR is MapReduce. So both of these components together form the heart of Hadoop. This stores things up. How again, if I have a 1 TB file, how will it be stored inside HDFS?